Hello, Assalamu alaikum, Mariam. Am I audible? Mariam Lahani,
Yes, sir.
how are you, Mariam? Fine.
सर आपकी आवाज़ फिर धीरे हो गई।
Am I audible clearly?
नहीं सर,
Yes,
क्लियर नहीं
Amna,
है।
am I audible clearly? नहीं, आमना से पूछ रही थी ना, आपको तो क्लियर नहीं है, ठीक है।
यस सर,
Yes,
क्लियर
आमना
है।
टेल मी, am I clear है? मरियम, आपकी तरफ से कुछ कोई दिक्कत है? How is it now? Is it any better?
सर
मरियम,
कब बीच बीच में मतलब जा रही है आवाज़, अभी आ रही है।
आपके पास ईयरफोन्स हैं? ईयरफोन्स में सुन रही हैं फिर?
नहीं सर, ईयरफोन्स हैं जी।
From Rawls law, and in this class we're going to start with colligative properties. Colligative properties. We first of all start with the definition of colligative properties. What does it mean and everything? Then we have to study in detail the four colligative properties. We will go on the details of those colligative properties. Okay, so what are colligative properties? The properties which depends, these properties, they will depends only on the number of only on the number of colligative properties and not on the nature of particles. ठीक है, तो डिपेंड किस पे करेंगे? नंबर पे डिपेंड करेंगे, नॉट ऑन द नेचर, एंड दैट इज व्हाई दे आर आल्सो नोन एज एकेए डेमोक्रेटिक डेमोक्रेटिक प्रॉपर्टी। They are also known as democratic property. There are four colligative properties. By the way, I will sometimes say colligative properties as CP. That is as like I will write. It's not that CP का मतलब हमेशा colligative property हो. Okay, it's not generalized in chemistry. For the sake of convenience, we are going to sometimes refer colligative properties as CP. There are four colligative properties. The first one is relative lowering of vapor pressure. Please write these things with me. We will call this as RLBP. Second, we will learn about the elevation in boiling point. That is represented by delta TF. Third, depression in freezing point. This is represented as delta. Wait a second. ये delta TF नहीं होगा, my bad. This will be delta TB. And this will be delta TF. Fourth is osmotic pressure. Osmotic pressure is represented by capital pi. Capital pi, small pi is not very different. This is small pi, this is capital pi. Okay. Hello, assalamu alaikum, Rafiya. Am I audible?
वालेकुम अस्सलाम सर, you're audible.
Morning, Rafia. Fine. Yes, Rafia. Hello. How are you? Good. You're fine. Rafia, go. Rafia, you don't need to write this like theoretically here. Please raise your hand once you're done. But Rafi, you were audible. Like when you replied, na, जब आपकी आवाज आ रही, then you were audible. Like, Amna and Mariam, raise your hand if you're done writing. Waiting for Amna. Rafi, are you still writing? Rafia, are you still writing? ठीक है. Hopefully यहाँ पे बहुत कुछ there is not much to explain yet. So one thing we should also write. Please write this. Qualitative properties are studied for solution of non-volatile solute, that is a solid solute in volatile solvent. In volatile solvent. Now volatile will be solvent will be that means liquid. ठीक है. So थोड़ा सा यहाँ पे I'm just going to explain you a bit. You don't need to write anything right now. Please don't write anything. The solutions, the type of solution that we are studying are three types, or you can put them in three different categories. We are studying binary solutions, okay? And in binary solution, we are specifically dealing with solutions in which the solvent is always liquid. So for that, we have three different. आपके पास क्या है? एक है liquid plus gas. Now, when you have liquid plus gas, I need you to carry your mic on, by the way, and answer. Let's suppose we have this liquid plus gas, A, and gas is B, solvent and solute. So which has more escaping tendency, liquid or gas? Like which will move faster? Amna, Mariam, and Rafia. Which will move faster, liquid or gas?
Yes.
Not reply to this. Gas will move fast, right? What happened? Amna and Mariam, you don't know what will move faster. Yes, Amna and Mariam, keep your mic on.
Yes, sir.
Keep your okay, fine. Mariam, also keep your mic on. Now, if gas is moving faster, then gas will be escaping the solution more easily. Make sense, yes or no?
Yes, sir.
Gas will be escaping more easily, and that is why you will have more gas particles above the solution. And the escaping tendency of gas will be infinitely more than that of liquid. Right? Liquid, they are hold together with each other. Right? They are with the molecules of liquid, they have intermolecular forces of attraction, but gas molecules do not have that. So you will have more of what particles, gas particles here. So we can say that pressure will be directly proportional to the amount of solute you have added. That is why we have the Henry's K into pi. Next solution we saw was liquid plus liquid. That means liquid A plus liquid B. Now, if I make a situation here, then both of these are liquid. And both of these things are what liquid. That means the vapors here will be of both liquid A and liquid B. The total will be whatever the total pressure will be whatever the pressure applied by the vapors of liquid A and whatever pressure is applied by the vapors of liquid B. The amount of so the pressure that is applied by A will be dependent on what PA will be directly proportional to type A and PB will be directly proportional to type B. And from here we get the details of the rods. The next is we have liquid plus solid. A and this is B. Now in this type of solution, which will have escaping tendency more, solid or liquid, which will have higher escaping tendency. Vapor किसका बनेगा, liquid or solid?
Liquid.
Liquid only, right? The solid will not make any vapors. So whatever the pressure we are having here will be directly proportional to the amount of solvent that we have added. So this is the starting of relative lowering of vapor pressure. Okay. So we will come into detail, but I'm going to start from here by the way. Okay. When we will write the formula for relative lowering vapor pressure, we'll start from here. The pressure of solution will be directly proportional to I. Okay. But first of all, write the heading relative lowering of vapor pressure. Relative lowering of vapor pressure. Please write this again. The vapor pressure of solution with non-volatile solute is directly proportional to the mole fraction of solvent. The mole fraction of solvent, because only solvent is what solvent is going to have the escape tendency, not the cell. It is directly proportional to the solvent. Okay. So pressure of the solution is directly proportional to the mole fraction of solvent. So I can say the pressure of solution will be equal to the P naught of A into chi A. And this P naught is same as we have seen in the Rawls law, that P naught is what it is the vapor pressure of pure A. Okay. Then P solution will be equal to P naught A into chi A. Okay. So now what we can write, chi A can be written like this. We see P naught A into 1 minus chi B. Okay. Multiply the P solution will be equal to P naught A, okay, into minus P naught A into chi B. Okay, P naught A into 1 will be P naught A into minus chi B will be minus P naught A chi B. Now what we will do, we will flip this, we will take this here and we'll take that solution there. So we'll have P naught A into chi B is equal to P naught A minus P solution. This part here, तो थोड़ा ध्यान से समझने की कोशिश करेंगे. If you write, please stop your hands. ना, don't write now. This was the pressure before addition of solute. है ना? That is the vapor pressure of pure air. Correct है guys? This one please tell me. Make sense?
Yes, sir.
बोलो तो भाई मरियम राफिया. Yes ना? Now what is this? This is the pressure after. Please don't write now. If you're writing, please leave your pen aside. Pressure after addition of solute. Let's suppose initially the pressure was 10 and after adding it became 6. So this difference, it went from 10 to 6. So this difference, that is 4, it is going to tell you about the lowering of, vapor pressure. Initially it was this much. After adding the solute, it became this much. Makes sense? Yes or no? Please tell me. This P naught A minus PS is going to tell you about the lowering of vapor pressure. क्या ख्याल है? Tell me guys.
Yes, sir.
Makes sense? No, no. Look, but let's suppose we were initially we were at 100 and it got decreased to, let us suppose, 98. Okay, and in another case, initially it was, let us suppose, 10 and it decreased to, अच्छा इसको 90 पे नहीं करके split it to 95 है ना, then you will make more sense. From 10 it decreased to 5. So decrease in the lowering in the vapor pressure is same in both of them, that is 5 units. Make sense? Yes or no? Please tell me.
Yeah.
Amna, Mariam and Rafia. Correct? But where do you see more decrease in A or B? What will you say? Where there is more decrease in the vapor pressure, A or B? Something went from 100 to 95. Is that a greater difference, or something went from 10 to 5? That is a greater difference. क्या ख्याल है आपको?
A1.
Which is greater decrease? Where there is more decrease according to your term? Think and tell me.
100 to
Something went
95.
from 100 to 95. That is greater decrease. 10 to 5. So
Lowest.
you're fine if you lose. Let's suppose. नहीं, yes. Think in monetary terms. You had 100 rupees and you have 95 now. Will that make you more sad? Or you had 10 rupees and you have now 5 rupees. That will make you more sad. Oh, what happened?
B.
Amna, Mariam, Rafia. B case is greater decrease. Amna, makes sense? Yes or no?
Yes, sir.
Mariam, you are not in the class. Mariam, are you not there in the class?
जी सर हाँ
Sir, आप reply क्यों नहीं कर रहे? Should I take your name and you will reply?
सर उतना ऑडिबल नहीं हो रहा है तो थोड़ी मुश्किल हो रही है इसको
Now you can hear me clearly, but when I am asking questions, then you are not able to hear me.
नहीं सर क्लास मतलब आपकी आवाज नहीं आ रही है
That's what I'm asking. Na? Like right now you can hear me, Abhi. Correct? Like when I'm asking whether I'm audible or not. Okay, but you try to see what's the problem. Na? Because Rafia, I'm clear, Rafia, right? Or is it low? Rafia,
But sometimes
I'm clear, right?
it's sometimes not audible.
Sometimes it's not audible. Amna, is it the same with you also?
Sometimes, sir.
Sometimes.
वो बीच बीच में आपके पास धीरे चली जा रही है
Okay, how about now?
अभी
Is
तो
it any
सही
better?
कभी कभी वो धीरे चली जा रही है एकदम
I will see then. There is some problem in my mind. Okay, so this is the lowering of vapor pressure. I hope you can see that if we don't have the idea of initial value, then lowering of vapor pressure does not give us the correct idea. है ना? अगर आपको ये नहीं पता कि initially आपके पास कितने थे, 5 रुपए का जाना, it is a relative term, right? If somebody had only 10 rupees and 5 rupees is lost, that's a huge loss for them. But if somebody had 100 rupees and they lose 5 rupees, that's not a big change for them. So that is why what we do, we relate it to, we divide this thing by the original vapor pressure. So it will become like this. IV will be equal to P naught A minus Ps divided by P naught A. Now, this is going to give us the correct answer. Like, for example, in the initial case, the A case will be having 5 upon 100. And in the B case, we'll be having 5 upon 10. So 5 upon 100 is going to give us like the loss we had is 1 by 20. And the loss here we had is was half. So this is a greater loss, meaning greater lowering in the vapor pressure. That is why this relative term is very important. And we define relative lowering of vapor pressure by this term only. And this is what this whole thing is known as relative lowering of vapor pressure, RLV. Okay. So I hope you understood that why we did not stop at lowering of vapor pressure and we came till the RLV. Will you please copy this down? Raise your hand once you're done. Raise your hand once you're done. See, now, you don't need to write this whole thing. I just want to show you something. Like when we have pure solvent, then in this case, what happens? Like only the solvent particles are on the surface. And whatever is in the surface, they have a tendency to move out. They can escape and they can get vaporized. But when we add solute particles, solute which is solid, the solute particles will also occupy some of the surface area. And solute particles, when they are occupying the surface area, then please remember, earlier there were solvent molecules which are replaced by solute particles. So the amount of solvent particles on the surface has decreased. And that is why the evaporation has also decreased, because evaporation is a surface phenomenon. And in the surface, if you're having less number of solvent molecules, the evaporation will also be less. And that is why what happens? That is why the vapor pressure, that is why we get less number of vapors and the vapor pressure decreases. Okay, so you will write this point here in solution. With non-volatile solute the surface has both solvent and solute. Solvent and solute particles. And only solvent particles can escape to form gas. Therefore, vapor pressure decreases. Waiting for Marvin. Rafi, are you done? Rafi, are you done writing? Okay. No need to draw this diagram. Okay. Rafi, हो गया आपका ठीक? Next, we will look at the graph for the relative loading of vapor pressure. So, graph के बारे में like generally I repeat this every time. Graph is always made from an equation. Okay? So without an equation in mind, please don't try to think of a graph. Think of an equation, and then you will understand if there is a graph or not. We have while we were deriving for the relative lowering of vapor pressure, we got the equation that pressure of solution it is equal to P naught A chi A. We can draw a graph for this, and the graph for this will be y is equal to mx. That means passing through the origin, and the graph will look something like this. Okay, so this is the graph. That means pressure of the mole fraction of solvent and the vapor pressure. Another graph could be made from this equation. The pressure of solution will be equal to P naught A minus P naught A into pi B. Okay, so this can be also graph. And here we will have this as the y-axis. Mole fraction of the solute as the x-axis. Whatever is with the solute, that is minus PA, this will be your n, that is the slope. And this P naught A minus P naught A will be the slope. Positive P naught A will be the intercept, the y-intercept. And the graph will look something like this. So it is a slope with an intercept type of graph. It will be like this. So here we are going to have the vapor pressure of the solution. Here we have the mole fraction of the solute. The slope here will be equal to minus P naught A. At this point, the intercept, intercept will be P naught A. Okay, please write this down. All of you understood the graph? Yes or no? Please tell me. Amna, Mariam, and Raf.
Yes, sir.
Yes, sir.
Mariam and Raf. Yes. Waiting for Mariam Lohani. Mariam, just waiting for you now. नेक्स्ट थोड़ा से हम आपको डिटेल बताएंगे रिगार्डिंग हाउ टू यूज दिस इन द केस ऑफ न्यूमेरिकल्स. ठीक है, सो प्लीज राइट फॉर न्यूमेरिकल्स we are going to use a bit different equation for the relative lowering of vapor pressure. When they ask for relative lowering of vapor pressure, फिर आप ये sentence लिख के and then you can write this mathematical form the relative lowering of vapor pressure. But this is not very useful for the numericals. For numericals आपको क्या करना है? For numericals we have seen that P naught A minus the P solution divided by P naught A will be equal to chi B, and chi B is the mole fraction of solute. Mole fraction is moles of solute divided by moles of solvent plus moles of solute. Now we will flip, like we will do inverse in the both cases. Just give me a second. Okay, just give me a second. Yeah. So we will just inverse both of these equations. It will become P naught A upon P naught A minus P solution, which will be equal to number of moles of solvent plus number of moles of solute divided by number of moles of solvent. And we will further separate this Na upon Nb, Nb upon Nb. So we'll get P naught A upon P naught A upon P naught A minus Ps, which will be equal to number of moles of solvent upon number of moles of solute, plus it will be 1 because Nb upon Nb it will be equal to 1. Make sense till here? Yes or no? Please tell me, guys.
Yes, sir.
Yes or no? ठीक है, चलिए. Now we'll take this one on the left hand side. It will become minus 1. So we'll have P naught A minus P naught A upon P naught A minus Ps minus 1, which will be equal to number of moles of solvent divided by number of moles of solute. Now, when P naught A minus Ps, if I multiply, like I will take LCM and everything, so this P naught A minus Ps will be multiplied by 1. So denominator में पूरा क्या आ जाएगा? Will have something equals P naught A minus Ps. Here will have P naught A as it is. Minus will be having P naught A minus Ps. which will be equal to number of moles of A divided by number of moles of A. Does this make sense? Yes or no? Please tell me again. किसी को ना समझ में आया तो बताएं. Amna, Mariam, Safia, all of you understand this? Yes or no? Till here?
जी सर.
I am taking LCM, right? So I have multiplied. सब कुछ है ना? ठीक है. Okay, so I will now open the brackets. So we will have P naught A minus P naught A plus PS divided by P naught A minus PS, which will be equal to number of moles of A divided by B. So P naught A and P naught A will be getting cancelled because times there or zero there. And you will get the ratio of solution divided by P naught A minus PS will be equal to number of moles of solvent divided by number of moles of solvent. Okay, so this is something that you can use and you will be very comfortable in getting the number of moles, or they generally ask for weight and everything. Okay, what is the mass of solute and what is the mass of solute? You can use this in the cases of numericals. You have to see that you will have a direct relation. You don't need to calculate the mole fraction and everything. You just need to calculate the number of moles of solvent and solute. Okay, you have to individually आपको दोनों मिल जाएगा. So please copy this down. This is what we are going to use for numericals in order to get answers quickly rather and quite easily. Sometimes they will ask you the number of moles of solvent or solute, and they will not give any data on the other component. उन केसेस में ये आपके पास काम आएगा. Raise your hand once you're done. Just waiting for Amna. So from here further you can write. Please see. PS upon P naught A minus PS will be equal to number of moles of A can be written as the mass of solvent divided by the molar mass of solvent, and moles of solute can be written as the mass of solute divided by molar mass of solute. So that will go in the numerator. It will become molar mass of solute like this. So you can write this also. So from here you can calculate the molar mass of solute. Determination of molar mass of solute can be determined from here. Okay. So you use this equation if we want to determine the molar mass of the solute. Generally molar mass of solute के लिए ही use किया जाता है qualitative properties को. ठीक है. Now you write next point when the number of moles of A is very high than number of moles of B, or the mass of solvent is very high than the mass of solute. ठीक है. अगर आप neglect कर सकते हैं उन चीजों को ना, in that case, like when you can neglect the mass of solute or mass of solvent, then what will happen? Please see. हमारे पास original equation है P naught A minus PS divided by P naught A. This is equal to number of moles of solute, number of moles of solute divided by
number of moles of solvent plus number of moles of solute. So in the denominator, since we are adding number of moles of A is very large, उसमें कोई छोटी सी चीज ऐड करेंगे, then it will not create a significant difference. Therefore, what we can do, say that neglect number of moles of B in the denominator only, okay? Because in the numerator we only have number of moles of solute. So यहाँ पे we don't have anything to compare with this numerator part. Here we have something to compare. ऊपर में आप अकेला 1 रहेगा ना, तो if you have only 1, then also it is significant, like you cannot neglect that. But if you have 1000 plus 1, यहाँ पे इस 1 को neglect किया जा सकता है because it is comparatively very low than 1000. ठीक है? That is why you can neglect it in the denominator, not in the numerator. तो जहां पे भी आप उसको ना सी से कंपेयर कर रहे हैं, whenever you are comparing with someone, कंपेयर मतलब एडिशन या सब्ट्रैक्शन हो रहा है, तब जाके आप उसको नेगलेक्ट कर सकते हैं, नॉट इन मल्टीप्लिकेशन ऑल्सो. मल्टीप्लिकेशन में नेगलेक्ट नहीं किया जाता. You'll get P naught A minus PS upon P naught A, which will be equal to number of moles of solute divided by number of moles of solvent. Divided by P naught A is equal to mass of solvent divided by molar mass of solute and solute. NB upon NB कर दिया, NB upon NA हो गया. And here will be having the mass of solvent. Above we'll be having the molar mass of solvent. So you are going to use this when you have this case. The mass of solute is very high, but it is very large compared to the mass of solvent is very large compared to the solute. इसको जरा लिख लीजिए. Waiting for Amna and Marie Lohani. You will try to do quickly 2 questions. All of these qualitative properties, they're going to be getting repeated in the Van Hoff factor portion. See here, please don't write the question. I will explain this. ठीक है, उसके बाद फिर आपको solution को लिखने की कोशिश कीजिएगा बस. ठीक है, no need to write the questions. By the way, this question is in NCERT. I don't remember. Question लेकिन NCERT में. ठीक है. So a vapor pressure of pure benzene at a certain temperature is 0.850 bar. The vapor pressure of pure benzene. Pure benzene, that means you're talking about P naught A. P naught A इन्होंने दे दिया है. So whenever you get a number, now you try to assign something. Like, what is that? P naught A, it is equal to 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 gram, that means mass of solute is given as 0.5 grams. When added to 39 gram of benzene, the mass of solvent is given as 39 grams. So from here only we can say that the mass of, this is quite high. Mass of solvent is quite higher than the mass of solute. 0.5 or 39 is बहुत ज़्यादा difference, right? So we can neglect 0.5 in the equations. Okay. Moving forward, we have what is molar mass यहाँ पे दिया हुआ है. Molar mass of the benzene, it is given as 78. Vapor pressure of the solution, that means PS, it is given as 0.845 cm bar. What is the molar mass of the solid substance? So we have just now seen the equation for this, that P naught A minus PS divided by write this in y. P naught A minus PS divided by P naught A will be equal to WB upon MB into MA upon WA, right? ठीक है ना? हाँ. So what is P naught A? P naught A is 0.850 minus PS is 0.845 divided by 0.850 is equal to molar mass of the solute is 0.5 multiplied by the molar mass of solvent, that is 78, divided by molar mass of solute that we have to find out. Achha, we have to find out this, so I will not write MB and again I will just write X, okay? X and multiplied by X नहीं लेते हैं. X and multiplication फिर आपको कभी confuse हो सकते हैं. So we write multiplied by WA. WA it is 39. So 39 2s are 78, I guess, right? है ना? So this will get cancelled as 2 and 2 into 0.5 will be equal to 1. So यहाँ पे आप देख लेते हैं कितना आ रहा है value. So this will be 0.005 divided by 0.850, which is equal to 1 upon MB. So we can write MB. It is equal to 850 upon 5. क्या ख्याल है guys? Make sense? Yes or no? Please tell me.
Yes, sir.
Right?
Yes.
So this will be equal to how much? 170, I guess, right? 17 fives are.
Yes.
170 grams per mole will be the unit and the molar mass. 2 into 0.5 will be 1, है ना? 2 का half 1 होता है. Copy this down. Amna waiting for you now. Amna just write solution है ना. ये सवाल you need to redo this by the way. Whatever questions I am doing in the class ना, that you have to redo. आपको दोबारा करनी ही है वापस से.
Okay.
Okay. Done ना? ये सवाल तो खैर बहुत ज्यादा नहीं है but please repeat these questions है ना. You may understand it while I am doing it, okay, but you will not understand it like you get the question. देखिए जैसे ये सवाल है, this question is a bit tricky है ना. यहाँ पे like you will feel that you have not been given much information. So first of all, they are saying an aqueous solution of 2% non-volatile, 2% non-volatile solute. 2% non-volatile solute का मतलब क्या हुआ? As soon as you hear this word ना 2%, so it will be always by mass. ठीक है? If they have not specified whether that percentage is by mass or by volume, by mass, by volume, then वो मतलब it's generally it is by mass, but you can also take it as per your own comfort. Like if you need mass by volume, then you can take it as mass by volume. If you need volume percentage, then you can treat it as volume percentage. But generally, it is mass percentage. So as soon as you get this 2% non-volatile solute, then you will write the statement or the translation as I have explained in the earlier classes. 2 gram of solute dissolved in 100 gram of solution or 98 gram of water. Because we are going to deal with the mole fraction, that is why mole fraction is solute and solvent we have treated individually. We don't need the solution component in the mole fraction. That's why I'm taking solvent right now. Another translation will be the 2 gram of solute dissolved in 100 gram of solution. And why 100 gram of water, sorry, 98 gram of water? Why I have taken 98 gram of water? Because it is aqueous solution. Exerts a pressure of itna bar. Okay? Exerts a pressure of itna bar. That means the pressure of the solution, it is given as 1.004 bar. At normal boiling point of the solvent. Normal boiling point of the solvent क्या है? Water का normal boiling point temperature कितना है? At 100 degrees Celsius. What is the molar mass of the solute? They're asking molar mass. Now, as soon as they set the temperature 100 degrees Celsius, what is the vapor pressure of? What will be the vapor pressure of solvent at this temperature? At 100 degrees Celsius, the vapor pressure of water is going to be 1 bar. Not 1 bar exactly, that is 1.013 bar, I would say. That is, pressure at 100 degrees Celsius will be equal to 1 atm. Because that is the definition of boiling point. What is boiling point? The pressure at which the vapor pressure of solvent is equal to the external pressure. And normal boiling point by external pressure will be 1 atm. And 1 atm, it is equal to 1.013 bar. So this is the P naught E. And then they have asked the molar mass of the. So when they have given water, so water के लिए आपके पास this 2 grams is what? WB. This is WA. Because it is water, we also have the molar mass of the solvent that is equal to 18. Okay. So where was the tricky part? The tricky part was here. They have given no information about the P naught E, but they have just said at the normal boiling point. Normal boiling point suggests some temperature. And at that temperature, what will be the pressure of the solvent? The pressure of solvent will be equal to the normal pressure. Normal pressure is 1 atm, which can be converted to 1.013 bar. Does this make sense? Yes or no? Please tell me.
Yes, sir.
And you बताएं. Amna and Rafia, makes
Yes,
sense.
sir.
Okay, so this is how sometimes they will give you the value. So even though they did not give you this 1.013 bar, but it was here. This number was written in this particular phrase, normal boiling point. Okay, so from here we can calculate that P naught A minus Ts. Here also you can see that 98 gram and 2 grams, we can ignore that WB part. P naught A minus Ps divided by P naught A will be equal to the mass of solute multiplied by the molar mass of solvent divided by the molar mass of solute multiplied by the mass of solvent. So we can plug in the values and get the answer. P naught A is 1.013 bar minus 1.004 divided by 1.013. Mass of solute is 2 divided by mass of, this is what we have to calculate, multiplied by the molar mass of solvent, it is 18 divided by 98. And how much will be this value? 0.013 minus 0.004. 0.009, I guess, no? Divided by 1.013 is equal to 49, I guess. 18 upon 49. And here we can write 9 upon 1013. Because here in the numerator also we have 3 digits after decimal. In the denominator we also have 3 digits after decimal. So you can remove the decimal point directly. So it is equal to 18 upon 49. And 9 2s are. Where is the MB part? Right? यहाँ पे MB है ना? 49 के साथ MB भी होगा ना? I forgot the MB. So MB will be equal to MB, it is equal to 1013 divided by 49. MB goes that side in the numerator, 1013 goes that side on the numerator. And you will approximately get how much?
40 के करीब आंसर आएगा, आई गेस, राइट? A bit more than 40, because if it was 1000 upon 50, it would be how much? No. हाँ, 1000 upon 50 में कितना आता है आंसर? ओ, 2 मिस कर दिया हमने ना, एक सेकंड, into 2 भी होगा, into 2 भी होगा. Here we had 2. So still 1000 upon 50 will be equal to how much? हाँ, सही सही, 40 हम ठीक कह रहे थे ना, 40 approximately 40 तो होगा. This will be 20 and into 2. हाँ, ठीक है, approximately it will be 40. A bit more than 40, आप इसको कैलकुलेट कर लीजिए. This will be, I guess, 41.3 grams per mole. Here, please copy this down. Hello, Assalamu alaikum, Sufyan. Am I audible?
Yes,
How are you? Fine.
fine.
We'll start in 1 or 2 more minutes. Okay.
Okay.